In this video, we're going to talk about graphing log functions. So if we're going to start with a log function that's in the basic form of log base b of x, where I can really use any value I want for b, I'm going to do a couple examples. Log base 2 of x equals y. Let's put that in exponential form. That would be 2 to the y power equals x. Now let's think through possible values. 2 to the y power. So let's start with a y value of 0. When I have a y value of 0, 2 to the y power equals an x value of 1. 2 to the first power. When I have a y value of 1, 2 to the first power is 2. I have an x value of 2. 2 to the second power is 4. 2 to the third power is 8. On the negative side, negative exponents make positive fractions. So if I have a y value, an exponent of negative 1, we know 2 to the negative 1 power is 1 over 2 to the positive 1 power, which is just 1/2. If I had a negative 2, it would be 2 to the negative 2 power, which is 1 over 2 squared, which is 1/4. If we think about that in terms of a graph, we're graphing 1, 0, 2, 1, 4, 2. We have to get out here to 8 to get up to 3. And then the 1/2 on the x-axis right here, if I graph 1/2, I'm at negative 1. 1/4, I'm at negative 2. So we can see how we're going to use those negative y values, which happen to be the y values this time because y is our exponent. Those negative exponents make positive fractions. All of those positive fractions are going to get me closer and closer to 0, which is the y-axis, but I'm never going to touch it because I'm always going to have some positive fractional amount, which leads us to the asymptote, which is x equals 0, because x will always be greater than 0. Again, when we have negative exponents, we get positive fractions. Y, our exponent, is negative. We're getting closer and closer to 0 as y gets more negative, but we're never going to get to 0. So x is always going to be greater than 0 for this basic log function. If we do a similar problem and just change the base, log base 6 of x equals y. Again, I'm going to think through it in exponential form. So 6 to the y power equals x. I can make a table of values. Y is my exponent, and I'm raising 6 to the y power. So let's think through some negative y values, 0, 1, and 2. 6 to the 0 power is 1. So we know that x is 1 when y is 0. So we can graph that. We had that on the last one. X is 1 when y is 0. That's in common for all of our log base b of x equals y functions, because b to the y power equals x. No matter what b is, b to the 0 power is equal to 1. So we would have that ordered pair 1, 0 on every function in the form y equals log base b of x, just your basic log function. Now, if we look at the base 6 and raise it to the first power, we get 6. Raise it to the second power, we get 36. So that means it's going to take all the way to 6 just to get up to 1, 6, 1. And then those negative exponents make positive fractions. So 6 to the negative 1 is 1/6. 6 to the negative 2 is 1/36. So since y represents our exponent, as y decreases, x is a positive fraction getting closer and closer to 0, but never touching it. So now we've graphed y equals log base 6 of x. We can graph log functions using technology, but using technology, we need to have a base of 10 when we put in our log function. So we're going to use the change of base formula in order to graph one of our log functions. So if I took the example of log base 6 of x, y equals log base 6 of x, that doesn't have a base of 10. So I'm going to use my change of base formula, which just says that that would be equivalent to log of x divided by log of 6. Remember, when you don't write the base, it's understood that the base is 10. So now using your online graphing technology, we're going to start off with log of 6 divided by, and I had to put that in parentheses, notice, log of x. I guess that's a teaching moment. I had it backwards. It's log of x because we were doing log base 6 of x. So it's log of x divided by log of 6. Now we see our normal logarithmic curve where we have 1, 0, that common point. And then we can see 6, 1. And when we scroll out a little further, you can go over and see that we're at 36, 2, and so on. And as we get closer and closer to 0, it looks like we're on the y-axis, but we're not. Remember, we're getting closer and closer to the having an x value of 0, but we won't actually ever get to 0.